Hello, Longhorns. Today we're starting a new unit. It's going to be over trigonometric ratios. So make sure you dog ear in your notebook or start a new tab or however you try and organize your notes, but this is a new section. Okay, let's see if well, it's not moving. Let's try this again. Okay, let's see if it's working now. There it goes. Okay, there we go. Okay, so trigonometry is the study of triangles. We've already been studying some triangles already. We've done Pythagoras theorem. We've had 45, 45, 90 triangles, and we've also had 30, 60, 90 triangles. These are special triangles, and they have rules associated with them. Sometimes we can't use these special triangle rules, and so then that's when we use trigonometric ratios. Okay, so let's talk about our triangle components. We have triangle A, B, and C. We all remember that, right? We have our right angle shown right over there. Let's see, right there. There we go. Okay, so we know we have one leg, two legs, and then across from it, our longest side, which is also always across from the right angle, is our hypotenuse. We label our angles, right? We can label them. This could be labeled angle A. Oopsie, A. This would be angle B, and this would be angle C. All right. Now we're going to add on to that by a few more terms. So we have our same A, B, C triangle with our right angle here, but instead of calling this angle A, we're going to call this theta. So theta is a way of finding an unknown angle. You can also call it your angle of interest. So instead of calling this angle A, we're going to call it angle theta. Okay, theta can never be your right angle. Well, one reason why, look, we already know what our right angle is. It's 90. Okay, so in this particular case, theta can only be in the position of over here by A, over here by B. All right. So our next components are opposite. So opposite across angle theta is our opposite side. It's on the opposite side of our triangle. The next side is adjacent. It's the side adjacent to angle theta. Remember we discussed adjacent angles before? They were the angles that were right next to each other. They were kind of next door neighbors. So this side is right next to angle theta. And then the good news is the hypotenuse doesn't change. It's still always right across from our right angle, and it's our longest side of our triangle. Okay. So our trigonometry ratios, we can help find any unknown values of angles or sides by using these identities. So we have sine, cosine, and tangent. Well, if you look at your calculator, you've never seen sine like that. What you've seen is sine, abbreviated, cosine, abbreviated, and then tan, abbreviated. Okay, so that's how we would see it in our calculator. So when we start talking about angle A, sine is equal to the opposite, the value of the opposite side over the hypotenuse. Okay, so sine A, we talk about this angle right here, is equal to the opposite over the hypotenuse. Let's do cosine A. So cosine A, we're going to use our same A angle right here, is adjacent. So remember our adjacent side is right here over our hypotenuse. And finally, our last identity we're going to discuss is tan A. So tan A is equal to opposite over adjacent. Okay, get some ways in which it can help us memorize these ratios. All right, let's look at sine first. So sine is equal to opposite over hypotenuse. So sine opposite over hypotenuse. Cosine adjacent over hypotenuse. Tan opposite over adjacent. You notice I've underlined certain ones of the letters. So together, those little letters bring up SOHCAHTOA. So S, sine opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. So write that down, make sure you have it in your notes, and refer to it until you get it all memorized, okay? All right, let's do an example. So find the ratios for sine A, cosine A, and tan A. So we look at the sides of the triangle, we have a 3, 4, 5. Well, if we remember, that's also a Pythagorean triple, but we're not discussing that today. So let's go on and look at this angle. So we're trying to find sine of A, okay? So the opposite side from this angle is 3, the number 3. Okay, so it's 3 over 5. Cosine, this side right here is adjacent, right? So the number is 4. So it's 4 over 5. And finally, tan doesn't include the hypotenuse. It's just opposite, 3 over adjacent. So it's 3 over 4. All right, let's look at the next one. Example 2, find the ratios for sine theta, cosine theta, and tan theta. So remember, theta just is our angle of reference or our angle of interest that we want to find. Remember, it can be either side of the triangle. It cannot be over the right angle, okay? So it could have been on this side or this side. All right, so let's look at this just like we did when we were finding sine A. So the side across from an angle theta is 1. So that's our opposite over hypotenuse. Now we do our adjacent. Adjacent is right here on the side of theta. So that's radical 3 over 2. Radical 3 over 2. See if I can go back and get that 3 covered in. Nope, it doesn't like it. Okay. And then tan is equal to opposite over adjacent, which is 1 radical 3. Now we can't leave our radical 3 in the denominator, right? We don't like that. Just does not like my 3's today. Okay. So it'll be radical 3 all over. Nope, it doesn't like the 3's. All over 3. Okay, let's move on to the next one. Okay, example 3. Find the ratios for sine x and sine z, as in zebra. Okay, so we have our sides labeled, and I gave us our little ratio. Sine x is equal to opposite over hypotenuse. So let's look where x is. This is angle x right here. So opposite of it is 12. And where's our hypotenuse? Is 13. Okay, so let's find sine of z. So we use our same ratio, opposite. I'm just going to put OPP over hypotenuse. We're just going to write it for short. So opposite of angle z, though, is this side. So it's 5 over 13. Okay? Let's do number 4. Find the ratios of sine x, cosine z, and tan x. Ooh, we got a bunch of different ones to find on this one. Okay, so let's remember our ratio. So let's start with x. We're going to find this one first. So sine x is equal to opposite over hypotenuse. Okay, so the opposite side across from it is 8 radical 3. And our hypotenuse side is right here. It's our longest side, is 16. We can simplify that, right, to be radical 3, radical 3 all over 2. Okay, next one we're going to do is cosine z. So this is adjacent all over hypotenuse. And so let's see where angle z is. Z is right down here. So adjacent, so this is adjacent to it, right? So it's radical 3 over hypotenuse. Well, look at that. They're the same. So that also tells you the sine of an angle is equal to the cosine of the angle opposite from it. Okay? Finally, let's do tan. Remember, tan does not include the hypotenuse, so there's no way it's going to be the same. So the tan of x opposite, so it's 8 radical 3, all over the adjacent side, over 8. So this can be simplified to be radical 3. All right. Okay, last example. Find the ratios for theta. So remember we said theta can be our angle of interest or it can be our unknown angle. So theta is right here. So we need to figure out what ratio or what trigonometric function to use. So let's look at what we know. Well, we don't know this side, so that's no. Okay, we know this side. This is opposite, right? Excuse me. And we know this side. This is your hypotenuse. So if we remember our functions, that means we can solve for sine theta is equal to opposite over hypotenuse, which is equal to 8 over 17. Okay? So I included this so you had a detailed of all that we've talked about for your notes in case you want to draw any other pictures, just so that you have them. Have a great day, Longhorns.